afternoon. My name is Martin Price from the company Opto GmbH. I'm here with my colleague Karen Eman, and we are here to give a demonstration of our Cleanalyser system. So this is an instrument which is designed for analysing residual dirt on metallic parts, all kinds of automotive parts, small components that are integrated into engines and other mechanical devices. The purpose of the Cleanalyser system is to analyse residual particles which are deposited onto filter papers after calibrated washing procedures. So typically a manufacturer would take his part, he would wash it using a very specialised procedure, he would then drain that water through a filter paper such as this, and the residual dirt would be captured onto this filter paper, and we are then analysing this filter paper for all of the particles that are on here, both for size, for type, for concentration and numbers. So this is the instrument. It's been designed specifically for this application. It's combining a number of different elements. We have inside here a high-end video microscope system with a CCD camera and a zoom system, completely optimized optics. One of the key factors in residual dirt analysis is the overall resolution of the system, that it is able to resolve typically down to particles of 5 microns in size. So balancing the optical design with the camera chip size is a very critical factor which we've resolved very carefully here. So we have the video system here. We then have a motorized XY stage, and also with this 5 micron system, the motorized Z height. So we have a joystick control in X and Y, and then also a focus system integrated here through our LAN controller. Illumination is provided by a specialist ring light, which has an independent control on brightness. And then we also here have a polarizer feature, and this is a critical feature, critical function in determining the difference between a metallic and a non-metallic particle, as we'll show you in the software. So the slide itself is designed to slot directly into this receptacle here very, very simply. These are standard slides that we can provide so that it enables a customer to build an archive of and record of his cleanliness and his standards, so to keep a reference point of previous cleanliness standards. So into the software, I will need my help from my colleague Ms. Eman here. The software is designed to be really quite powerful. It allows a user to create their own standards of cleanliness or to be compliant with some of the industry standard specifications. So in the automotive industry, these would be ISO 16232 and VDA BD19, both of which the system is fully compliant with. In addition to that, you are able, as I mentioned, to create your own standards. So if you wish, you can create a standard which even exceeds those standards if you want to go past those, and the system will help you to do that and to build a roadmap of quality. So Karen, can you tell us a little bit about the software here? I can see a live view here. I can probably get us into focus a little bit here. Start to bring those in.
So to start with the measurement, we first have to choose the right module, the right layout, which was especially designed for having a good view on your sample, on your filter sample, which we can fix with these clamps here. And then we have to connect our stage, and we have to connect our joystick. We do this by clicking here and here, and then you can see that we can move the stage in X and Y direction, and we can focus with the Z axis in this direction.
So we've preloaded one of the most common standards here, which in the automotive industry would be VDA BD19. And this, you can see the red lines here show us exactly what the specification demands. So we have different size classes of particles here, so 5 to 15 microns, 25 to 50, 100 to 150, these are all in micron sizes, and then also the count. So this would represent the thresholds of count that we are permitted of particles, and as we go through the test, this will populate here, and we will see if we are in specification or not.
Yeah.
Is that right?
As soon as we get higher with our measured lines, we can interrupt the measurement if we would like. Okay, so
the software itself is quite useful, isn't it? Because it's we have this main control panel over on the right-hand side,
yeah,
and this seems to be in like a chronological order
Yeah.
of what to do next.
we can work from the top to the bottom,
Mhm.
and yeah, that's
Very good. So we've connected our joystick.
Yeah.
So now we have on the front here, we have our magnification settings. So inside here I mentioned that there is a zoom system inside here. This allows us to change the magnification of the system and to zoom optically the system up, not digitally or optically, if we wanted to get a much finer, much higher resolution in the system to start imaging much smaller particles. Of course, as we increase our magnification here, our runtime increases. So we are running at 0.75 here. We've already inserted that into the system here. So what's next?
Next thing we have to do is we have to choose a profile. That means we have to choose our measurement settings, how we would like to do the measurement. And all this is saved in a profile. What we will do in our example, we would like to detect metals, and that's the reason why we are choosing a profile calling 2-pass. So it's a drop-down list, we have the right profile.
So 2-pass means that the system is going to do 2 passes over the complete sample area. The first pass is going to be in normal illumination with the polarizer off, and then the second pass will be with the polarizer on.
Yeah.
This has the effect of the polarizer is a commonly used optical element which suppresses reflections in metallic objects. So using the polarizer on and off on a shiny object, you would be able to determine whether it was shiny or not as to whether the polarizer was on or off. So we do a 2-pass if we want to detect metals.
Maybe you can see it already here. So we have it to position on, so it suppresses the reflection, and here you can see that it's reflecting, so it should be a metal.
So the software will detect that, and it will detect that from pass 1 to pass 2, the reflection properties of that particular particle changed, so it's very likely that that is a metallic particle due to that performance. Okay,
so next step we have to do is we have to tell the software where is my filter area I would like to detect.
Okay. So the system is compliant with the standard in the industry, which is 47mm diameter filter papers, is that right?
Yep.
So what we're doing is we're telling the system exactly where that circle of interest lies in the system.
We are doing this by setting 3 points on the edge of the corner. It's like in this figure here. So we start with new, and then we are looking for one edge. So it's the first click. You can see here that it counts your numbers.
So that's 1 out of 3. So we're basically creating a triangulation, if you like, of the circumference of the filter paper.
Then second one, and third one.
Good.
And now you can see we nearly reached the 47 standard.
So the software now knows exactly where our circle of filtration occurred, and it knows exactly where to start that scan run.
Yeah, and you can see that going to the edge, there's a red line which appears, which shows you your filter area.
Yeah. So we also need to do a little bit of work on the illumination here, don't we? The system works on contrast and the contrast differences between the background of the paper and the dark particles. So it's looking for a difference. So we really need to kind of optimize that as much as we can, so it gives the software the best possibility to capture all those particles. So what Karen's doing here, she's adjusting the intensity of the illumination. This shows you the grey level performance of the camera here. So we're able to, by changing this around, we can move the intensity around. The optimum is sort of right in the middle there, about 50%. That will give us the best chance and the best, we're using the best range, the dynamic range of the camera there.
Okay, so what we can do here is we can set the threshold. You can see as soon as I go to this histogram, the particles or the part of the filter, what will be detected as particles, are appearing in red.
So this is really adjusting the sensitivity of the system. It's adjusting the sensitivity of the algorithm in detecting the particles, essentially, and you can control how sensitive the system is. You need to balance this quite correctly to make sure that you're getting all the particles in.
Yeah, so I would test it on different areas, just to have a good average value. Okay, so when we've done this, one important point, take care that the polarization filter is on.
On, right, on for the first pass.
For the threshold
okay.
detection. And then we can start the measurement. Start with run.
So it's asking us there to make sure that the polarizer is off now for this first run.
So we off.
And to check that our zoom position is as we've told it up here at 0.75, which it is. So we're ready to go.
We confirm.
So now the system switches into a different view now. We've got this complete overview of that 47mm patch virtually here. And you can see that each of the fields of view is being captured as the stage is moving here. This is one of the fastest systems on the market for this as well. And what's also interesting, as we do the second pass, you'll see that data is being populated into here live. Data is not coming in here yet because it needs to do the second pass in order to determine whether there are metals or particles. It obviously needs to do the first pass without the polarizer and then the second pass with the polarizer. Once we've done that, these fields here will start to be populated. But this is very, very quick. We use an industry-leading stage here, so we really are able to get quite a lot of speed up doing this. What's also nice is that we can, another nice feature that we have in the system is that you can abort the run. A lot of systems with typical automated microscopes and what have you, it's difficult to stop the system once it's started. We have an abort button right here, which is also really useful if on the second pass you find that you fail very quickly. So if the system detects a metal particle that's very large, it's going to tell you quickly and you would be able to abort the system then and save yourself time. So that's also another nice feature. So we have a bit of a wait now, just whilst it comes to the end of this first pass. It's building us up a very nice high resolution image there. We can see that there's quite a high density of particles here, some large ones. We even have what appears to be a fibre up here as well. And just coming to the end, it's then going to go back to the beginning, and it's now telling us that it's going to start the second pass and to put the polarizer on. So this now will suppress those reflections from the metallic particles. So the software now is looking for changes in the value between the first particles and then the second measurement of those particles, and it's looking for the difference. So what we can start to see now is that our histogram is beginning to build here. So I mentioned earlier that our red line is the threshold of VDA-BD19, and we have this color coding here, which is very nice. So this is the blue is the count of everything, the red is the maximum, and then we have these nice three here, which are fibers are green, metallics are this cyan color, and then other classifications are yellow. So what do we see here already? We've got a failure straight away on VDA-BD19. So on the 25 to 50 micron counts, we've way exceeded that. So this would be a failure straight away on that. So it's really working very, very well. Also now you can see that we've got a class failure here also, and also a bit of a population appearing on 100 to 150. So this has come from an object that was very dirty, and that would probably then, this would tell the user that he would need to take all that batch of samples and put them back through his cleaning procedure, rewash it, and then come back to this, and then keep on going. So it would provide an ongoing verification procedure for a manufacturer and a cleaning process to ensure that no dirty parts are delivered to a customer. Once we get to the end here, we should then be able to see all of that data building, and we can move on to analysing that data and exporting it into a standard report that can then be filed. So it's just coming to the final end of that pass now. So we move into now this new phase now, this new layout, which now starts to give us all of these different layouts, and I'm going to have to pass back over to Karen now to give us a summary of that.
A summary of the windows.
Of these different windows of the results here, of what we've got.
So on the right side here, you can see our control window. So it stays in the same position. Here, this is the most, let's say, interesting part, because here we can see all metals or all particles that have been detected.
So how many particles is it actually counted there? I noticed that every particle has an ID number now, every single one.
And you can see
2,513 particles we've counted, is that correct?
That is correct.
Yeah.
You can see it here, and you can see it in this window. So this window shows you the particles sorted according to a standard. In our case, it's the VDA standard.
Yeah. So here, just to reiterate that, so the VDA BD19 standard is saying that in the red column here, the maximum, and this is why it's turned red now, is that in the 50 to 100 micron class size, the threshold limit is 250. We are allowed to have 250 particles of this size in this area. But the reason it's red is because it has counted 259 metallic particles, so it's a failure.
It's the sum.
Yeah.
It's the sum in total, not only the metals or fibers or whatever.
Yeah.
It is allowed only to have 250, and we have 900, more than 900.
Yeah.
So
it's a very, very good, very quick way of seeing that you have a failure instantly. It does all of the analysis by itself, completely independently, based on these embedded reports. And the VDA BD19, as I mentioned, is standard. It's already fitted in here. So all you have to do is just select it as an option directly.
Anyway, you can change this here at any time, before the measurement, after the measurement, doesn't matter. Okay? And let's have a look on this window above. So this window shows you more features, more details on the particles which we can select in the table.
So whatever's highlighted here, you get this detailed view up here. Okay.
Yeah.
And just for the video, we have the full length. So we get a little highlighted box around the particle here. This is telling us that the length is 36 microns, the width is 14 microns. It's classified as an other, i.e. it's not a metal, it's not a fiber, so it's just classified as a general particle. The area in pixels that it takes up, and then we can actually modify this as well. You can put whatever you like in there. There's a drop-down menu. We won't confuse you with that, but you can have all number of things here.
There are many features that are mentioned. Okay, so when we would like to have a look on a certain particle, for example, the biggest one, we can do this by activating it in the table and then clicking to go to. And you can see that the stage is moving.
So every single particle has its own reference point, obviously. So it's very simple for the system then just to go to each one individually, and the stage will move and activate.
Just can click, and it will be driving to the position.
Yeah.
Okay.
Very good.
So you can also check, for example, when we say that what the software is doing, it's typed as a fiber, for example. So we can check if the particle is a fiber. When we go there to the biggest one, you can see, okay, it is. You can also see if it is reflecting or not.
Yeah.
No, it isn't. What we can do, we can mark the particles. Maybe we need to have a special look on the biggest one. So we can mark it, clicking the particle, go to, add a name, and press set. Do it with,
Yeah, so you might do this, for example, if you just wanted to take the top 5 biggest particles.
Yeah, I want to highlight them because they can cause or most probably they will cause the major damage on your component.
Right, I see.
So for many customers, it's quite interesting that they are reported in a separate slide.
And this is all leading to us showing you the report module, which is coming next. So things that we're marking here will then feature in the report that we create, which again is just literally a one-click button. Okay, that's good.
So should we do this?
Let's do that. Let's have a look at the export. So we have a number of options here. The most popular by far is Excel. So an export directly into Excel. So if we drop down this box, we have a number of different things. We can export raw data. We can do all kinds of other things. But an Excel report is by far the most popular. The system as standard comes with a number of templates in here according to the type of layout that you'd like to do. There's a lot to choose from. So do you have that opened?
The layout?
The template layout, yeah.
The
template is done.
The template is done, the details are done, so the report head, we call it report head.
Yeah, so it's ready to go.
So it's ready to go.
So in here, if you wanted to as well, in the report that Karen selected here, there are a number of different fields, and these are all customizable by a user. So it, for example, might have your customer's name, your order number with him, and all kinds of other things relating to your order with your customer. And it might be an operator, it might be the username and this kind of thing. Anything that you wanted to be included on a quality report. So once you've filled all those in,
just confirm.
Hit the OK button.
Looking for the directory to save the file.
So we could save that onto a network or onto the local drive or what have you. So Karen's clicked save, it's opening up Excel, and there's our report straight away, auto-generated with all of the data contained within. So it breaks it down to the different tabs here. So we have, there's our information that we entered all about the customer details and perhaps an order number or this kind of thing. We also have, sorry Karen, is there?
These would be also interesting. So we have your resolution you measured, then with threshold we are using.
Yeah.
And the phase fraction means the relation from particle to filter area.
Right.
Here we have the overview.
So this is all part. This is sort of page 3 of the report. So it's quite a detailed report that the system is generating here.
These are our marked particles.
Very good. So
we've done before.
Yeah.
Here you can see the histogram according to the standard we selected.
And then of course we have the same table that we saw where I pointed out where the failures were. It's also giving us that as well. So it's giving us that complete class list of all of those particles and how they're broken down into fibers, metallics, etc.
That's a more statistical view.
So inside some of these specifications like ISO 16232 and VDA BD19, you'll know that there are much more detailed requirements, and I mentioned that the system is fully compliant with those. So this particular report gives us also a lot more detail about those too. And then finally, the images that Karen tagged are also contained here. So whichever particles are marked, where we mark them just after we've analysed, they will also be included in the report, again with each of their individual attributes as well. So the height, the ID, the length, the width, the type, and all this kind of information. So that's really a summary of the Cleanalyser 5 micron system, one of the market leading systems here in Germany for residual dirt analysis and cleanliness verification. Thank you for listening.